right, so now that we understand a little bit how to write logarithms and to switch back and forth between exponential and log form, we can use that information to help us evaluate logarithms. Now, we should be able to do quite a few of these without a calculator. If you have a copy of your perfects chart, then that would be handy to pause the video and find that before you get started. So the main thing to remember, which we've said before, but I will repeat multiple times, is that logs equal exponents. So the answer to a log problem is always going to be a missing exponent associated with that base. Now, knowing some of our exponent properties are going to be very useful. So remember that when I have anything to the 0 power, that is going to equal 1. When I have a negative exponent, that always makes the reciprocal. And when we have a radical, we can rewrite that using exponents. And that is what we're going to need to do here. There's no properties of radicals when it comes to logs, but we can use what we know about exponents. Okay, and again, your perfects chart will be very helpful here. So if we look at number 7, it says evaluate each logarithm without a calculator, but you may use your perfects charts. So when I have the log base 2 of 32, and that equals some unknown number. The question that this is asking us and what we're going to think in our head is this means that 2 to some unknown power equals 32. That's what we are trying to figure out. Now, if we look at our perfects chart and we want to know what power of 2 makes 32, we're going to look at the row where the base is 2, and I can see that 32 is right here in our n to the 5th column. So that means 2 to the 5th equals 32. So that tells us that the answer to this log is 5. The log base 2 of 32 equals 5 because 2 to the 5th power equals 32. Let's look at another one. The log base 4 of 16. So again, the question is, if the base is 4, what exponent gives us 16? And so the answer to this one is going to be 2. Again, that is because 4 squared equals 16. Logs find missing exponents. That's the big thing that you want to remember, okay? Now, if we look at number 9 and 10, these are a little bit trickier, and this is going to tie back to our exponent rules here. So if I have the log base 3 of 1 over 9, that tells me 3 to some power gives me 1 over 9. Well, I know that 3 squared is 9, but remember that if I want to make the reciprocal, that's where I need a negative exponent. So the answer to this is going to be negative 2, and that is because 3 to the negative 2 is equal to 1 over 3 squared, which is how we get 1 over 9, okay? Number 10 is a little bit tricky as well. So this is asking us, if the base is 49, what exponent makes 7? Well, I don't necessarily know an exponent, but I do know that the square root of 49 is equal to 7. And the square root can be represented by the 1/2 power. Okay, so I know that the square root of 49 is the same thing as saying 49 to the 1/2 power, and that is how we get 7. So with those ones that appear like radicals, that gets a little bit trickier. So you will need to use your perfects chart. What I would like for you to do is pause the video and try 11, 12, and 13, and 14. You can back up on the video to where I had the perfects chart on there so that you can look at that on your screen if you need to. But pause the video because I'm going to come back with these answers in 2 seconds. Okay, so for number 11, you should get 3. Now, again, we look at our perfects chart. The question is, if the base is 9, is there an exponent that gets me to 729? And we see that right here. So that is in our 3rd power column when the base is 9. So that is why we know that the answer is 3. Now, number 12, we have to rewrite a little bit. We want to think of this as the log base 3 of 9 to the 1/3 power. okay? And so this says if the base is 3, what exponent makes this 9 to the 1/3? Now this one is extra tricky a little bit here, okay? So I know that to get to 9, it's got to be 3 squared. But then I also know that I need that to be to the 1/3 power. And remember that when we do a power of a power, we multiply those exponents. So 2 times 1/3 tells me that I'm going to get 2/3 for this exponent. That one is a little extra tricky. You got to think of a couple of levels there. Number 13, I need the base to be 16, and I need the answer to be 2. Now, the fact that this number is getting smaller is a big clue that I need to think in terms of a radical. Now, what I do know is that 2 to the 4th is 16, so that means that 16 to the 1/4 is how we get 2. So that is why the answer there is 1/4. And then number 14 is asking 8 to what power equals 8? And that has to be 1. 8 to the first power equals 1. These take some practice, just kind of knowing what you're looking for, but take the time to go ahead and use that perfect chart and practice those without a calculator. You need to be able to do those on your own, okay? In the next video, we'll talk about a couple of log properties. Whoops.